Hello everyone. In this video I'm going to showcase this shop stool tutorial designed by David. It's a beginner level tutorial. The main thing I like about this tutorial is that the entire shape, everything you see over here, including this twisted legs and everything, is done using just cylinders. And the way this is done is using more of the artistic tools, kind of bending and things like that. So it's a quite good exercise to see how you can modify topology and keep them flat in the bottom, twisted the way you want it, nice looking like this, and using just a cylinder shape. So let's get started. Okay, so I've loaded this tutorial over here, and you can see it has 97 steps. It's relatively, average size tutorial, I guess. More to the shorter side. And the first thing it says activate the cylinder from 3D shapes. So I'm going to go to cylinder, and it's just going to modify the cylinder sizes. So it's going to give a radius of just 2, looks like, a very small radius, and the bottom also 2, so it's symmetrical. And the height would be 150, and then segments would be 50. So we'll make it quite smooth. This means we can modify it, and this also 50. So relatively simple, and then we click on finalizing. Okay, so you can see what we did over here. I have to zoom into it to see we created a very small tiny cylinder, and now we're going to go to cube selection. So the idea here is to select parts of it, and cube selection is a very powerful tool for when I want to select parts and make an exact cut. So what we can do over here, we can select the size if I know the exact height size that I want to select, or we can go percentage wise. So in this case, we're going to select percentage wise, and we're going to select from the bottom, click 80. So that means that we're moving up the cube by 80. As you can see it over here highlighted in yellow, this means it's moved up by 80, so which means we're going to select only the top. So it doesn't mean bottom, doesn't mean we selecting the bottom, it means move up this from the bottom, so it ends up selecting from 80 to 100, which means only 20% of the shape is being selected. And I'm just gonna scroll down over here to show you, it's not mentioned over here because we don't change it, but the default exact selection is on. If exact selection is on, it means it will actually cut into the cube. It's a knife tool in this case, so it means it's selected exactly, and we get everything over here. Okay, so now I'm going to finalize it, and as you can see, this part is selected. So now we're simply going to rotate this part, and we're going to go to the advanced settings and change the rotation so it should be to the bottom. So by default the rotation is in the center, and we want to rotate it from the bottom. So, and now we're going to rotate around the z-axis. If you see over here the line over here, the z, so we're going to rotate around the z in this way, and by 270. So that basically gives it in this direction. So we have it over here, and yes, so now we're going to close this one. Okay, before I don't actually have to close it because we're going to go to another transformation, and these type of tools don't have a checkbox because they're kind of active tools that you can have with others. Yeah, so I can just go to the move tool, it will automatically switch it to this tool, and now we're going to move the x to -17 just by 2. As you can see, you can move it down to, say, type it in, -17. Okay, and now we're going to go out of this tool. And now it's red, that means I have to deselect. I can just click on the grid to deselect. And now we're going to, so what we did over here, we moved it kind of, it is still, it's not self-intersecting, you sometimes have to be careful with that. That's probably why we moved it. So after we bend it from the bottom, it might give it like a sharp bend that may make problems, and we move it away to kind of smooth out this part over here. Now we're going back to the cube selection, and now we're going to select from the top 185, meaning we actually move it down. 85, I'm sorry, not 85. So we move it down to select just this section, and the same thing, exact selection is still selected. And then we take this, and now we're going to go to the bend tool. So if you remember, we added a lot of segments before. We're not in the wireframe mode, you can't see it, but if you remember from the settings, we added a lot of smoothness, so they will have enough what to bend. And now we're going to do the same thing. We're going to set this to the top. So now we actually want to bend this using from the top, and we're bending on the x to 65, which basically means this. So the top means it's where the slope starts, where the peak is, So actually we're bending away from this. So this is where the least is on the top, and then it goes from here. If you bend normally, it will be from the center and will kind of be like an arc shape. In this case, it's actually, this way. So no need to explain, you can see actually what's happening. Okay, so now we have to deselect this, and we got this part. Now we're not finished yet, we're gonna make another cut. We go to cube selection, we go again to percentage wise. So the first time we did percentage, second time size, and now percentage. This is just, I guess, the way the designer visualizes what's easier to find the sections. That's, just optional, the way you find them easiest, whatever works for you. And now we're gonna bend again this section, and again we're gonna send it now to the top. So we're going to bend the section from the top over here, and we're going to bend it to minus 170. So we basically flatten this down here to the bottom like this. And now we're going to polygon selection, and we're going to select the bottom over here. So I have to activate the polygon. Okay, so I have to select like this, select this bottom. So what you see over here, what happens is this is not straight. I couldn't even select it as one polygon. We had to I had to use marquee selection because they're all bended and they're not flat, and this entire thing is not flat over here. So what we're going to do here is we're going to go to the flatten tool, and we're simply going to set, you see there's offset from this entire thing as you select them has more than one unit. So we're going to make it to 0, and now we got this completely flat. Okay, now we have to deselect this, and we have our base from this. So now we're going to go to the move tool, and we're simply going to set the Y to 0, so we want it to be on the floor, and we're going to set the X to 35, so positioning it away. So why do we set them 35? Because we're going to go now to copy offset. We're going to rotate this around the center, so we're positioning it already how far we want this to be away, so that we can rotate the center. Because you can see this top over here is about at the center. We'll see soon. So we're going to use the pivot tool, which is a tool that rotates around the center over here and can make copies while rotating. So we're making 3 copies. Click copy, and as you can see over here, yes, this wasn't the top. You see we left some space over here. So if we go down, but this is away, so this is exactly how it should be, and we're done. So now what we're going to do here is we have the basic shape created out of a cylinder. Now we're going to use another cylinder to create other parts over here. So let's see, we're going to set this height to 15, so we give it some thickness. This is the seat, I guess. And now we're going to add the segments to 50. We give it again some smoothness. While it's in this, even if you don't have the wireframe on, while it's in this mode, they have their own settings for wireframe, which you can see here now what's happening. Okay, so now we're going to set the Y position to 120.5. So we don't have to move it later. You can position it immediately like this, and we're finalizing it. I said before about the difference between X and a check mark. These tools you cannot open anything else because they're like an application by themselves. They have to finalize it. If you think about transformations, you can jump between others. They are more of a tool that is more integrated into the general flow of the application. So that's the difference. Okay, so now we're going to go to polygon selection, and we're going to select this polygon. Now we can select them as one. Before bending and twisting, they become a single. They stay as a single polygon. And what we can do over here is, let's see, it tells me to select also the top. And let's see what we're going to do over here. We go to edge mode. Okay, so what we go over here is we're going to activate the edge mode, which means it's going to select the outer edges. So if you see over here, if we go down to edge mode, it selected the outer edges that are part of this polygon. This is actually interesting, something that it's worth explaining. You can select technically the top using face mode. I can just select them, same at the bottom, and marquee select, because a cylinder is very easy to select because they all connect to the center. I can just marquee select in the center, and it will select all of the faces. However, if you select the face mode and then you go down to edge mode, it would select all of the edges, including the inner edges. If you go first to polygon mode and you select them as a polygon, doesn't matter if it's flat, I can select them, or I can marquee select them, doesn't matter how. But if they were selected using the polygon and then I go down to edge mode, it will select only the outer. That's a way of SelfCAD exposes these different type of selections. So if you want to have only the outer edges, this you can do it. There's another way to get the outer edges. You can simply loop select edges, go to edge mode and advanced settings, so loop select, but this is probably easier to do. So that's basically what we have over here, and now we're going to fill it to add some smoothness over here. So we're going to add the intensity to 5, which is how far the offset is. That's basically intensity. And then we have the level is the smoothness. So level would also be 5. So we're basically smoothing it out over here. And then what we do over here, some parameter settings, and bevel offset to 1. Okay, so this make to 1. So what's happening here is that we can bevel it. Let's see what's happening over here. So this is the same thing that we did kind of before, where you move it from. So you can move it from the center, or you can move it from another location, like move it up to medium. I mean, it could be negative or positive. This is how the calculations goes from the arc that is doing it. One will kind of give it this bulk move. It's actually, see, it moves up, pops up. If you do it negative, it will actually go inside. And the default is 0.5, which is a typical bevel. So in this case, we wanted to get this kind of bulk move. It's actually the first time I see in a tutorial using 1. I've seen using before as a typical bevel. Usually we see plus 0.5, and I've seen using minus 0.5 when you want to make an inner bevel. But using more than that, minus 1 or plus 1 in this case, actually it's the first time I think I see over here, so I'm glad to see it. Okay, so it's actual good use case for it. Okay, so now we're going to go on other cylinder, and as I said, everything is done using cylinders. So now we're going to do radius 2, another small cylinder, and the bottom two is symmetrical, both there's just small, and the height is going to be 230, so it's going to be quite big. There's also something here worth explaining. The sliders are limited how much you can move them, so typically most sliders you can move only to 200, but it allows you to override them by entering more numbers. This is just the way the UI works, so you have to have a minimum max. You cannot make the slider move to whatever. So so the value is limited by moving the sliders. By typing in, it's limited by the size of the grid. So if you size the grid would be 10,000, you can type in 10,000. In this case, the default workspace settings is like 750, so you can basically type in 750 or something like that. Or actually, yeah, I think you can type in 750, yes, because it's in the bottom. Okay, so now what we can do over here is the segments would be to 100, so it's going to be quite smooth. And then what we can do over here, this segments would be 50, so this is basically more segments in the horizontal than the vertical side. Looks like we're going to bend it in one direction. Actually, don't know, I haven't tested this. And now we're going to position it to Z to 36. Okay, so it's basically positioned over here, and we're finalizing a cylinder. Okay, so what are we going to do now? We're going to bending. Okay, yes, so we're going to bend it in this direction, which is where we need the smoothness, and we're going to use dynamic origin. Okay, so dynamic origin is something very interesting. So let me explain what this is doing. Whenever you bend something, it basically reshapes it, but we start bending around a point. It could be the default is, let's say, the center point, or you move it top, bottom, whatever point it is. Let's say the default is the center point. If I move it from the center, and if I start moving it, it's in the center, that's how I start. But if you, as you bend them, the center gets also shifted. So the next bend, let's say for example we bend it 1 unit, it's still in the center. If you go the second unit, the center is no longer center. So now it will be offset, and that's why you cannot make a full circle when you bend the 360 degree. But dynamic origin will shift the center point along with the bending, meaning making it always to be in center. So that's basically what it is. So if you turn on dynamic origin, and this is usually used when you use 360, a full degree bending. So if I make it minus 360, which is a 300 minus 360, I must have typed something wrong. Okay, so if you see over here, we bend it around the center, and it gave us, we're just closing the tool, it gave us a complete loop, which is, let's say, I think we're going to see it after rotation. So we rotated the Z by 90, and you can see over here, okay, we can go to move tool now, but we just basically putting it into the center. Okay, center and Y to 100. Before I move it to Y to 100, let me just show you over here what you have. So because we use dynamic origin, we basically bend it from the center, and the dynamic origin kept on shifting the center point, the pivot point, so it gave us a full 360 degree and it's closed. Without dynamic origin, you would have had some gap over here, wouldn't be perfect. So this is a brilliant feature. I haven't seen it in other software, but it's actually quite good. It's used a lot. Okay, so now we're going to move it up to 100 and basically just position it where this is supposed to be to give it a support for these legs. Now we're going to copy button. So we're going to copy this, make another copy from it, and we're going to make the Y to from the gizmo. It tells me from the gizmo to move it. I'm not sure why it's using the gizmo for this, but we're going to switch it down to 25. So we moved it down, but here we have to scale it, so you can just guess. Now we're going to use scale because this part is wider. So we're just going to scale it, keep a portion. We want to scale it and resize it, I guess. And we're going to make it here to 107. Okay, so it's actually a strange design. I'm not sure, I'm not a designer, but just what the keep a portion did, it's not just scaled it to fit over here in the two directions we needed to scale, which is the XZ plane. It kept proportion, basically scaled in all directions, so meaning is this tube size over here is bigger than the tube size over here. So I guess it's just a design preference. Could have done it the other way as well, kept the same size, but yeah, that's just a preference. Okay, so now we can do over here, we're going to go to the edge mode, and we're going to, deactivate edge mode. We were still in the edge mode from before, so I just clicked again to deactivate it, and we're going to select, let's see, and we're going to group them. What do we do over here? Yes, okay, so we're just going to group them, and okay, so now we're going to go geometry clean. Actually, you know, it's just the flow the way you did it. Usually we're going to fix here, so I'm going to explain first what the problem here is. So if you remember, we created this tube using bending. The cylinder had a top and a bottom. The way we selected, like the same this cylinder has this top and has this bottom over here. When you bend them, they don't disappear. You just kind of take the bottom and make it round, wrap around and touch the top. So that means that there is two faces inside, I mean more than one face, but two planes basically, two polygons, which is the top and the bottom, and they're stuck here inside, someplace where we started. Let's say we started bending from this point. So at this point you have inner faces from the top and from the bottom that are still inside, and that makes all sorts of issues. Obviously it's not manifold because you need to remove it. So there's something fixing. I would normally fix it first before I make the copy and move it down, but I'm assuming the designer first did the copy because it's saving some steps. I guess when you do it in the same, while you have open the move tool, you just make the copy and move it, so it makes it easier. I don't know. But in any case, what we're going to have now, we have to fix the top and bottom, both of them, because they're copied from the same thing that has these faces. So we go to geometry clean, and this is what this tool is very good. It has, first of all, remove duplicates. After you remove the faces, this sometimes it makes a difference what you do first, and sometimes it works, but it's good to know the logic what's going to happen, because sometimes this will work. So if you think about it, if I just remove duplicates now, there's nothing to remove, because duplicates means when you can merge two vertices. You have a certain point that connects from one side one vertex, other side another vertex, and they need to merge together so they become one vertex instead of one. In this case, you cannot remove duplicates yet, because they have faces, so they actually belong to each other, because each one needs to represent their own faces. So you need to remove the inner faces. Actually, in the order of operation, you first need to remove the inner faces. After you remove the inner faces, you will still be left with the duplicate vertices. Then you can remove duplicate vertices. In most cases, SelfCAD application is smart enough to figure out how it should be done, but I'm just explaining this because in some cases you may find the order will make a difference. But nonetheless, if you click over here, let's see what's happening. You see it removed how many faces. We had quite detailed faces, so it removed faces and polygons, and now it's manifold. Okay, so now we're going to do it. So we're going to select all of these other parts, and let's see, are we selecting everything? I guess everything except the seat. And we're simply going to use stitch and scoop union. So I want to say here's something else about union also. So the union basically combines together everything. If it's not manifold, in some cases it may give a non-manifold error, and in some cases if it's just small issues, like let's say this interfaces we had, it may not give them non-manifold issue, it may still work. However, the union will not fix the non-manifold. It will fix when you intersect two objects, it will find the intersection and remove the interfaces. But if you already have a single object that has interfaces, it will not do it. So it's either magic fix that you have over here, or in more specific cases where it's easy to fix, like we have over here, we know what we're dealing with, we can use the geometry clean, which is much better. It doesn't have to rebuild the entire geometry. So yeah, so this is done actually the proper way, how it's supposed to be done. Okay, so now we basically done with the tutorial, the design part. Now we're just going to add textures and adjust styling. So we're going to go to the material section, and we're going to add a physical based material, which kind of it's not like in the renderer when you're going to render an image. You have real physics-based rendering, which is kind of really implemented to replicate in the real world how it looks physics, how the metal reacts with light and so on, so to make it look realistic. This is not 100% realistic, but it's as fake as you can get to make it seem like realistic, basically. But this would kind of make it look like a metal. It's not exact reaction. But in any case, we're going to make it now to give it the shyness, and we're going to change the color to this color, and going to finalize it. So this kind of makes it look like a metal. And now we're going to select the seat, and we're going to give it, in this case, we're going to give it a texture. Instead of just a material, we're going to add a texture to it, a wood texture. Looks like it's using wood 1. And now it's going to the UVs to make it look based on face UVs, to make it look nicer. And that's basically it. As simple as, very simple rendering settings. And yeah, it looks good. So it's basically done, how it's done. So if you can see, the amazing part of this is a relatively nice looking chair, and with the style, with everything, and it's done 100% artistically, done everything without with just a single cylinder, without any technical tools, just eyeballing it the way an artist does the best. Yeah, there is a similar tutorial from David. If I go back over here, this is this tutorial, the keychain holder, which has a very similar concept, but it created these hooks. But the hooks over here are created, instead of bending, it's using extrusion a different way. So there's different ways how you can do it artistically. So it's either you kind of build it out, use extrusion, how he created this really brilliantly, or in this case was everything bending. But the main takeaway from all of these shapes is that if you have an eye as an artist and you know how to visualize, how to use the tools, the sky is the limit. You can do whatever you want with all of these tools. When it comes to technical tools, it's more about understanding structures and geometric shapes and combining, subtracting. It's a different mindset. When it comes to artistic tools, it's mostly about whatever you can visualize. SelfCAD is great on both of these type of modeling, which is proven by these type of tutorials. Okay, hope you enjoyed it. Hope you learned something new. Please let me know in the comments if you have any questions or if you want me to show anything else. And have a great day. Bye.